Okay, the only way to get good at these Lewis structures is to practice. So we have only one choice, and that's to practice. So let's start by practicing with ammonia. So we have ammonia. Ammonia has N with 5 valence electrons. N is in column 15, has 5 valence electrons, and 3 hydrogens, so 3 times 1. So we've got 8 electrons altogether. The nitrogen is going to be in the middle because we learned that hydrogen can never be in the middle. So nitrogen's in the middle with 3 hydrogens placed around it. So you could place those hydrogens anywhere around it. There's no like rule about having the hydrogen be here or there or here or there. So it's just around the nitrogen. Then our next rule is to bond our atoms together. So we've got bonds between each of the hydrogens and the nitrogen. Now that represents 6 electrons, of which we have 8, so we get to put another pair on there. We can't put that pair on any of the hydrogens because they're too small. So too small, they're done. So we got to put that pair on the nitrogen. So that pair is on the nitrogen, and now we have to check the octet rule. Well, the hydrogens have like a unique duet rule, so they're done. And the nitrogen feels 2, 4, 6, 8. Everybody's satisfied? Hurrah! We move on to the next one. Hypochlorite ion. Well, chlorine has 7 valence electrons. Oxygen has 6 valence electrons, but then we've got this minus sign. Minus sign means there's an extra electron. Minus sign means there's an extra electron. So we got to add one more electron. So we have 14 electrons. 14 valence electrons and ClO minus. We put the Cl next to the O. It doesn't really matter who's center right now with the Cl and the O because they're just two neighbors, right? So we go ahead and put this bond between them. That represents 2 electrons. I have 12 more that I can place. So I put that 12, 6 on this guy, 6 on that guy. Okay, is the octet rule satisfied? Sure is. All done. Except there's a rule. There's a new rule. If your Lewis dot structure represents an ion, then you have to put brackets around it and put the ion charge out there. Otherwise, someone just looks at that and thinks you did it wrong, right? That you added a willy-nilly electron. It came out of nowhere. So you have to put the brackets and the minus sign out. Now, because of a old story with Corey Deemer, Casey Deemer's older brother, we have taken to calling those brackets the pants because the ions are embarrassed about their ionic charge and they can't go out without their pants on, so you have to remember the pants. No one calls it the pants except for Central Catholic students, but when they're missing their pants, I will say, oh, what an embarrassed Lewis structure with no pants on. It's more fun when we're in person, but maybe I'll write back to you that your structure was missing pants and how embarrassing. Okay, the next one, the nitronium ion, NO2 plus. We've got nitrogen who has 5 valence electrons because it's in column 15. We've got 2 of the oxygens who have 6. And then plus sign. Plus sign means we've lost an electron. Plus sign means we've lost an electron. So that's a -1 on there. Plus sign means we've lost an electron. So we end up with only 16 electrons. We've got 16 electrons for NO2 plus. So we look at N and we look at O. The lower and lefter goes in the middle. So that'll be the N. So this is a scary structure because I was always saying, oh no, oh no. Okay, so we're going to put a bond between the O and the N, so that's 4 electrons. We've got 12 more. Now, I'm getting out my pencil. It might be wise for you to get out your pencil too, because as we build these structures, we've got a method that will always lead us to the right answer, but that method can sometimes make us move our electrons around. So we've got 12 more electrons. The rule is we put them all out here on the oxygens. Okay, so I put in my 12 electrons. Now I check the octet rule. Obviously the N is unsatisfied. This O is satisfied, this O is satisfied, the N is unsatisfied. So I'm going to have to move those electrons into bond pairs. So I'm going to be moving this one into a bond pair and this one into a bond pair. And this is why the pencil part comes in. I want to completely erase those. If you use a pen and you scratch them out, you're going to lose points because a scratch looks like a line, and that's no good. So you want to use a pencil while building these. So I'm moving those 2 pairs of electrons in. So now I still have only 16 electrons. We'll count again to make sure. 2, 4, 6, 8, 10, 12, 14, 16 electrons. But now the oxygen perceives it has 8, 2, 4, 6, 8. The nitrogen perceives it has 8, 2, 4, 6, 8. This oxygen perceives it has 8, 2, 4, 6, 8. Hurrah! Don't forget your pants. I know in quarantine, like, pants are kind of optional, but pants are not optional in Lewis structures. Okay, let's do NH4 plus. Obviously, N is going to be in the middle. Oh, I forgot to count my electrons. We've got 5 for nitrogen, plus 1 for each hydrogen, minus 1 because of the positive charge, so that's 8 valence electrons. So we put a bond in to place. Oh, that's 8 electrons. Everybody satisfied? Put your pants on, move along. It's kind of funny working videos where I get to tell you to put your pants on because, you know, in quarantine, people aren't getting dressed. Like, they're wearing clothes. Like, let's not be weird about it, but they're like, when's the last time you put on uniform pants? I'm guessing it was March 13th. Okay, CO. C's got 4, O's got 6. That makes 10 altogether. Let's put the C next to the O. It doesn't matter who's in the center because they're just next door to each other. So we go ahead and put a bond between them. That's 2. And here come out my pencil again. 2, 4, 6, 8, 10. Not satisfied, not satisfied. Okay, so, well, we're going to have to share a pair. Share a pair, okay. So we do that. Okay, now the oxygen's satisfied, 2, 4, 6, 8, but the carbon's still not, 2, 4, 6. So the oxygen's going to have to share a pair as well. And there we go. Our first triple. Are you so excited? I'm so excited. Carbon monoxide, our first triple bond. Okay, let's do NO+. So N's got 5, O's got 6, that's 11, but it's plus. So we take 1 away. So it's got 10, just like the carbon monoxide over here. So we got 10. Let's see if we do that pattern again. What happens? Okay, so we go 2, 4, 6, 8, 10. Oh, seems like we've run into the same problem we did last time. So let's go ahead and move a pair in, and you get a triple. But put your pants on. Okay, SO4 2 minus. S in the middle. Because it's lower than O. 4 O's. Okay, this is going to have a lot of electrons. Sulfur's got 6, oxygen's got 6. So that's 5 times 6, 30. 2 more from the minus sign, 32 valence electrons. Let's rock and roll. 1, oh, sorry, got to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Everybody satisfied? Put your pants on. Go out to the party.